start the tutorial 2. And before we start the tutorial 2, I think the important ones, which are, I think we have gone through the lectures, if you remember that. The first one is definitely the different deep learning models, the conventional neural network. We have seen the CNN, so we are not going through the details, but please remember these are the things we are going to consider. And then following that, RNN autocoders. Then we have also seen a little bit of DNN and how the GIAN is important when we talk about creating synthetic damage data, right? Similarly, we have also talked about the reinforcement learning yesterday. So now, before getting into the step 1 or the tutorial 1, let's try to have a quick look into the how these different techniques work in the structural health monitoring. So they are basically showing the strength, limitations as well as the applications. You can see compared to the machine learning model, how the deep learning or the other models are showing the strength and the application results. This is a very good table to have a look into that. So now let's start with the first problem. So as I said that we will start using the PyTorch today. So basically it is the implementation of CNN based image classifier tool, and as we have seen in the last lecture. And what we will try to do today is that we will try to perform a practical step-by-step implementation of a conventional neural network for image classification by using the PyTorch, okay? And for a CFR10 data set, right? So the first step is definitely building a deep neural network using the PyTorch, and then we will try to focus on implementing the CNN-based image classifier. And before we begin the training of our model, we need to also import some of the necessary libraries and set up the environment. So I think you all must be aware of PyTorch for building and training the model, right? And then you also, so I hope you have the PyTorch which has been installed, and then the torch vision. So please remember that you should be able to having all of these models or all of these libraries in your MATLAB. Can you please make sure that you do install all of this? One is the PyTorch, then Torch Vision, then Matplotlib, then NumPy, then SSL. Can you let me know that you do have all of these libraries installed, everybody? Are you all okay with this? You all do have this? Okay, perfect. So now let's then move ahead with the final stage, okay? The next one. So now we are trying to import the libraries and setting up. So first is that we will try to import the torch vision, which will bring in common vision datasets, and so we have to import torch, okay? And this we are using for image transformation and visualization. So we are importing the torch vision here, and the next step is that we will import the so one is torch import is done, then torch vision is done, then we will be, so all of these libraries we are going to import here, okay? Similar way we are also going to import the NumPy as well, and then we will be importing SSL. So can you let me know if you have done this and if you have imported all of this? So one, this is being imported, all is being done. Then we will set the SSL text here, you can see this one, to create default. That means we try to context the bypass certification error, right? And this is we are going to do to control our flaws for better visualization. So now can you let me know if you have done this? And the figure size we have taken as 14:6. So you can change it if you want to, depending on the size we have taken it 14,6. If you want to increase it, decrease it, you can change it accordingly, okay? So once your importation is done, can you let me know that you have done the SSL and plot one? And as I said, if you need to import all of this, it has to be available in your MATLAB library or the Python library, whatever you are using. Done? Everybody else, is it done? Should I move to the next one? Then let me know once you are done. Yes. This is all you have to kind of import. This basically we kind of use to adjust the security image, right? Or to bypass the certification. Should we move to the next one? Everybody? The first one is representing the figure and second one is representing the figure size, right? Okay, so I'm moving to the next one, right? Okay. So now we will try to step by step talk about the data transformation plus loading the CIFAR, right? So let's go one by one. So first we define the transformation pipeline and how we do that with the transform.combo. This is the term we use for it, and this is actually let us change the multiple processing step by step, which is going to learn every time when an image is going to be read. So now if you will try to look into the inside the pipeline, you can see that we have used to tensor, which converts each of these PIL image to a PyTorch tensor, and that will scale. If you that, then we anyone, have you done till the normalization? Then we need to create the training set, right? So anybody has any problem till normalization with this line? We're using the transform normalization term. We move to the next one. Have you done till normalization? Have you done? Then can you try to and once you create the train data set, then similar way you also create the test very comparable. So once you create the normalization is being done, can you now create the train data set as well as the test data set by using the CIFAR10? Have you done that? Anybody else? Okay. Anyone has any other difficulties to create this? Are you able to create the train data set as well as the test data set? Okay. So now let's try to move to the next one, the next step. Here we will try to create the data loaders, right? So now how will we do that? That once our data sets are ready, then we wrap up them with the PyTorch data loader. And the data loader will try to handle the heavy lifting for us here, right? So first what we will do is that we will try to do the batching for the optimal shuffling, right? And that's what we have done. We have set a batch of 128 here. That is big enough for the good GPU or the CPU throughout, and they are stable gradient estimate, right? So can you try to kind of define the batch size? Once you define the batch size, then you will need to train the loader. And that is going to create the training pipeline that will yield the mini batches of the image level. And each of that is going to pass through the loader, and that is going to fit the model one batch at a time. So first you need to define the batch size, and then you need to define the train loader. Once you do the batch size, then you do the train loader. The next one is similar way, you do the trace loader. So trace loader is very similar. That is going to provide the batch data for evaluation. So we usually do not shuffle the test data, so that's the result of reproducible, right? So with this kind of loaders, then our training loop will become very simple and very fast. So once you define your batch size, you do the train loader and then you do the test loader. And here we are taking a batch size of 128. If you want, you can also kind of do more or less than that. And then we are creating the data loader. Let me know once you, at least most of you got this image. If you get stuck somewhere, let me know as well. Basically, have you taken the photos of this? You take the line, taken the photos of all this line. Maybe there is some missing comma or some bracket as there on the first part. same one she's doing, but some I think both the that's a two lecture. Yeah, he's doing Python. Yeah. Sums and all they are same. Okay. Understood where is the mistake? There is some space or some bracket problem is there. Got it? Got it? Okay. Okay, then we are moving to the next one. So once you got this image, the next step is to analyze the data sets to find the class distribution. Okay, so what we are doing in analyzing the data of class distribution, we will collect all the class labels from the training data and then we will count the occurrence of everyone, right? So for the first one, as I said that we will look into, yes. So this is very, very important because we need to know how many samples we have per class and that is going to help us if our data set is balanced or biased, right? Similar way we have done for each of the batches, we have taken this and we try to train the train loader. By using that we try to train the data and x and y is the data and then we are trying to extend the class with this, right? So we start by creating an empty list called classes, right? And then look through our train loader to collect all class labels from each of the batch. Okay? And then each of this loop we will try to extend. That we are going to do later. First, can you try to do the first part? So the first line is that we have tried to create an empty list of class, right? That's what we have done it as a classes. And then what you can do is that for each of the loop we extract the images and labels and here we have stored it as x and y and extended our class with those labels. You can see that. So classes.extend is going to be y to list. Next step is using the numpy, but before that can you try to do till the extension. So once we are done with that, then we will use the numpy unique function to count how many times each of this class appears in the training data, right? And then we get the class names from the data by using class to IDX here. You can see this one. So we can label our chart very correctly. And then finally we will try to plot as a bar, where the x-axis will show the target class. You can see that x level we have showed as a target class, whereas y level will show the number of training instances. So the x1 will go, x level will show this and y level will show this, and then finally we will plot it. So can you try to plot this and let me know how it could look like? Anyone else? Anyone else got the plot? Yeah. How many of you got this log? Got it? Okay, so now let's go to the next one. And here we will try to build a CNN architecture. Is this enough clear to all of you? So first we will try to do is that here we will try to focus, as we said, that we will try to build a conventional neural network, right? So the first step is that if we will try to look into this. Can you see now? Yes. So we will be trying to build a CNN architecture here for the classification, right? So as we said that, let's try to do the first step at a time. So first we will try to define the class CNN by using the torch-NN module, and then we will be defining in the initial cells, right? So can you try to first line write down the CNN and get this class, and please remember that it has to be installed in your library. Yes, I did. No, it is visible online. Not visible? yeah. I mean, they can share it. No, this is the main one. Can you check it again? So now if I am zooming in, can you see the zooming? So maybe some internet issues are there. Yes, hi Vivek. So you can see that I have tried to define the image size and number somewhere, right? So you can change that one, and if you use a different type of like if you don't use a CA10, then definitely your model will become like more complicated. So if you let me just show you the. Yeah, so here you can see that I have tried to, or I have talked about the torch vision and I have inputted the CFR10, right, to train the data set. So if you are not going to use that, then definitely you have to define the size of your pixel, define the size here. So you can see that I have also talked about the figure and the figure size. So those are the things you have to change according to that, right? So here I have tried to take in a very normalized case, but if you will take something more complex, definitely the whole process will some way similar, but yeah, so here is the term where you are defining the train loader or test loader. Before that, you have to define all of the test data set and details of the test data set, right? So basically nothing but here I have defined, if you will see then you have to, whatever data set you take it, you just load it here. And similar way for the test data set also, you just load it here. So it's going to be not too much different, okay? Once you have done till this one, have you taken the padding equals to 1 and have you done till this? So once you will be done with this one, then we are going to use that each will be followed by an RUL action, right? Or activation that to maximize the pooling layer. So that's what we have done it here. We have used the torch and RUL, and then we have talked about the maximum pooling 12B, right? We have used the kernel size equals to 2. Similar way, we have also talked about the output as well as the padding one. So now if you will try to kind of rewrite the whole things, basically we have tried to kind of do first with the class definition things. Basically we have tried to kind of do first with the class definition, right? And then we have done the second conventional block. So now first, and then we have done the second conventional block. So now first if we try to define the CNN, have you done till this one? Result you are gonna get it, okay, which is going to show you. So if you will do this properly, then you will be able to get a graph like this. Okay. So now once that's been done, the final step show the 5 examples. Okay, if you can increase it also depending on that. So I have tried to show the 5 examples from the test batch. Okay. And then similar way that y2 name we have given as name y2 equal to this one. So this is basically the time the 2 level indices into the readable class. Similar way we have also done it for the y-feed name as well. And this is also do the something similar. And then similar way we will try to look into the plot in show. We can show the plot title we have given, the plot axis we have not given the plot axis because we want to see just the images. And now if you will try to plot this one, you will be able to get up something like this. I can send you all the codes actually. If I think Shivu, you have the email ID, right? So I can send you all the codes so that you can just use it. Okay, yeah, I can send you all the codes for today and the last week, so you can just try to practice and get something like this. Okay. But it's all in MATLAB, so if you use the Python, the terms will be very much similar. Only I think some of them, and try to get something. So here I have shown you the image one. You can also do for text. You can also